End-to-End Observability in AWS. Cloud Services Infrastructure and Computing class, CSCI E90, Harvard Extension School, fall of 2023. Here is a project objective. Implement full-stack observability in AWS for a web application by generating and collecting logs, metrics, and traces utilizing cloud-native services provided by AWS. I used the following technologies: Amplify, Cognito, API Gateway, Lambda, DynamoDB, CloudWatch, X-Ray, and Cloud9. Here is the high-level architecture diagram. I adopted this project from one of the AWS samples workshops and modified it to my needs. This is a web application using which a user can request a write. Amplify is used to host the static website, including HTML, CSS, and JavaScript files. For user management, I used Cognito, which manages the user pool. The development itself is done using Cloud9 IDE, which integrates with code commit code repository. An API gateway is used to front the backend. Lambda is used as the backend written in Node.js. Lambda performs the core functionality of this project. I also used DynamoDB NoSQL database table for persisting records. Here is a screenshot of the application. We will see this in a demo shortly as well. User can click anywhere in the map and click a button for a write to be sent there. Cloud native observability. This is the objective of this project. AWS CloudWatch is going to be used to collect and store logs and metrics. AWS X-Ray is going to be used for traces. In addition, AWS CloudWatch RUM, the real user monitoring, is used for end user experience monitoring. When it comes to metrics, the out-of-the-box metrics provided by AWS CloudWatch for Lambda is more than sufficient. It monitors number of requests processed, duration, error rate, and throttle requests, and few other metrics. Here is a screenshot of the metrics page within the Lambda Monitor tab in AWS Console. Logs. Lambda logs messages into AWS CloudWatch. We can write our own log messages for troubleshooting, and that's exactly what I have done for this project, to write my own log messages. What I also observed is logs can take several minutes sometimes to show up in the AWS console. There is also an option to tail the logs live, but expect a few minutes latency. Here is a screenshot that shows a log record within AWS console. Traces. Traces by default are not enabled. Traces are done through AWS X-Ray service. We can enable active tracing using AWS console. Traces can be visualized in a segment tree that can be very useful to identify which function calls are running slow. When viewing a trace, logs corresponding to the trace can also be viewed in the same screen so that we can easily correlate. We can further take traces to the next level by adding X-Ray SDK or AWS distribution for OpenTelemetry and make some minor code changes to add annotations and also trace remote calls made by the function. Here is a screenshot that shows the segment timeline within a trace. The real user monitoring is enabled by using AWS RUM web package and copying a code snippet produced by AWS in the client's JavaScript files. By capturing real user monitoring information, we can analyze end-to-end data flow. Let's go ahead and dive into the demo. I have logged onto my AWS console. First, let's take a look at AWS Amplify, which is used to host the website. My website name is Mustang. From here, you can click on the app URL to launch the app. This is the home page of the app. The user management is done by AWS Cognito. I can click on the Giddy Up link here. Let's go ahead and log in. Once logged in, we can click anywhere in the map and then click on the Request Unicorn button. You will see a small graphic that shows a unicorn being delivered or sent to the location where you clicked. Let me go ahead and request a few more unicorns so that we can see the logs, metrics, and traces generated by them. Okay, great. Let's go back to AWS console and let's take a look at the Cognito setup. In Cognito, I have one user pool using which I can manage the users. Cognito provides a very easy way to manage users, including resetting the passwords, confirming their email status, and so on. Next, let's take a look at the Lambda function, which performs the core logic of this project. Request unicorn is the name of the Lambda function. The code is written in Node.js. The code itself is pretty straightforward. We initialize an array of 3 unicorns and then simply use them to deliver whenever an event arrives to the Lambda function. We also record the ride in DynamoDB. I had created a table called rides in DynamoDB and simply use that to persist records. Before we dive into the metrics, logs, and traces for this Lambda function, I want to note that an AWS API gateway is used to front this Lambda function. Let's take a look at that. While rides is the API gateway. And you can see I have a ride resource and a post method. When you look at the integration request, you can see Lambda is the integration type, and then the Lambda proxy integration is true. And this is important, and I had actually made the mistake of not enabling Lambda proxy integration. When you don't enable Lambda proxy integration in a resource in API gateway, the post message will not be delivered as a Lambda event when the function is called. So it is important that you have the Lambda proxy integration set to true when you create this resource. Let's go back to the Lambda function and look at the monitoring side of things. In the main Lambda page, when you scroll down, you can go to the Monitor tab and start to look at the metrics. By default, AWS collects several Lambda metrics, including the number of invocations, duration, and error count, all crucial for managing your Lambda function when it comes to monitoring. In any of these metrics, you can click on the 3 dots here and then click on View in Metrics to pull up the AWS CloudWatch dashboard that can provide more control to view the metrics. And please note that the time zone here is always in UTC. Usually, keeping time zone in the local time zone is useful. Also note that you can click on the I symbol here to get more details about a particular metric. In this case, duration, which is the amount of time your function code spends on processing an event. As you scroll down, you will start to see the CloudWatch logs. And you can see that already AWS has collected several log records. Let's go ahead and expand one of them. You see a high-level log record in this view. When you need to look at the actual log messages produced by your Lambda function, you can click on the log stream here, which takes you to CloudWatch log groups. Here, for this particular log stream, you can see the entire log record. You can easily add custom logs into your Lambda code. Let's take a look at that. In the code, initially I was having trouble deploying this Lambda function and making it work. So I needed to dump the entire event received by the Lambda function to troubleshoot. What I had done is simply added a console.log statement and printed the entire log event. You can see that in CloudWatch by simply expanding the log event. You can see that received event and then it prints the entire event. This was useful to me because I was troubleshooting the user authentication. With the Cognito integration, we are supposed to see the request context being sent as part of the event. Great. Now let's talk about traces. Under Monitor, under Metrics and Logs, if there are traces available, you will see it in here. I had enabled tracing. By default, tracing is not enabled. You can easily enable traces by going to Configuration, Monitoring and Operational Tools, and then edit the additional monitoring tools to enable active tracing. I already have some traces available. Let's go ahead and click on a trace. When I click on the trace, it opens in the CloudWatch window. And then here we have the full view of what happened within that Lambda function. For instance, the initialization refers to the start of the Lambda function itself. Usually the initialization portion goes away once we receive multiple requests. We can also keep an eye on the overhead if we are troubleshooting any slowness issue. One nice thing about X-Ray and AWS CloudWatch is the logs associated with the trace also shows up in the same screen, so you can easily correlate logs and traces in one screen. Now in the trace segment view, currently it is only showing the Lambda function. When you add AWS X-Ray SDK or AWS distribution for OpenTelemetry, we can also track the remote calls, for instance to DynamoDB, and also add custom annotations to your traces. Finally, in order to enable CloudWatch RUM, you can go to the CloudWatch page and scroll down to the RUM page. I had tried to enable RUM for my application. Unfortunately, it did not work and I had run out of time to actually fix it. To enable RUM, you first add an app monitor, which will provide the JavaScript code snippet that you need to add to your web application. Great, this completes the demo portion. Conclusion: use CloudWatch for metrics and logs, use X-Ray for traces. Majority of observability implementation can be done via configuration, which means you can use infrastructure as code. Consider adding your custom log messages for easier troubleshooting. Consider that the logs will not be available in real time as it can take a few minutes for processing. Observability cannot be an afterthought, it must be implemented from the beginning. Thank you for watching.